Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 The Quadratic Equation and its Numerical Roots M. Sandoval-Hernandez 1,2,3, H. Vazquez-Leal 2,4, U. Filobello-Nino 4, Elisa De-Leo-Baquero 1, Alexis C. Bielma-Perez 1, J. C. Vichi-Mendoza 1, O. Alvarez-Gasca 4, A. D. Contreras-Hernandez 4, N. Bagatella-Flores 5, B. E. Palma-Grayeb 4, J. Sanchez-Orea 4, L. Cuellar-Hernandez 4. 1 C. Betas 190, AV 15 Colonel Venustiano Carranza 2 DASECC, 94,297, Boca del Rio Veracruz, Mexico. 2 Constjo Veracruzano de Investigación Científica y Desarrollo Tecnológico, Coviacide, AV Rafael Murillo Vidal No. 1735, Cuauhtémoc, 91,069 Xalapa, Veracruz, Mexico. 3 Escuela de Ingeniería, Universidad de Xalapa, Carretera Xalapa Veracruz KM2 No. 341, 91,190 Xalapa, Veracruz, Mexico. 4 Facultad de Instrumentación Electrónica, Universidad Veracruzana, Circuito Gonzalo Aguirre Beltrán S/N, 91,000 Xalapa, Veracruz, Mexico. 5 Facultad de Física, Universidad Veracruzana, Circuito Gonzalo Aguirre Beltrán S/N, 91,000 Xalapa, Veracruz, Mexico. Abstract: in this paper an alternative procedure is proposed to obtain the proof of the general formula to solve quadratic equations, which can be taught to high school and university students. Likewise, the solution through power series is discussed, which can be used when there are values much less than 1 in the equation. In the same way, an analysis is presented on the significant digits at the roots of the quadratic equation. Keywords: quadratic equation, exact roots, school mathematical speech, significant digits. Introduction. In current times, pedagogy plays a very important role in the teaching-learning processes at each of the educational levels, since different learning strategies are used, such as the flipped classroom 1, project-based learning, meaningful learning 2, grid technique 3, etc. In the case of textbooks, there is a trend that is continuously repeated when content is updated when presenting a new edition, because when a new edition is published, as in 4 to 18, favorable changes are made in the pedagogy with which the thematic concepts are presented, more demonstrative examples are included, more proposed exercises, the use of more than one ink in their printing, the use of schemes and illustrations, etc. In other cases, the new editions incorporate the use of mathematical software such as Maple 19,20, MATLAB 21,22, GeoGebra 23, Excel 24, among others. However, there are contents that remain intact, preserving the school discourse. In mathematics teaching, school mathematical discourse, DME, is all the language that is introduced into a class. It is a system of reason that produces symbolic violence due to the imposition of arguments, meanings, and procedures 25,26. It is everything that remains unchanged despite the innovations in relation to school mathematics, since this innovation does not modify the concepts that are being taught, but the way in which it is being taught. 27. Many textbooks, such as those used in mathematics, are designed under the DME. It is frequent to blame mainly the teachers for the failure in the learning processes of mathematics, ignoring that the books are influenced by the same school mathematical discourse. 27. The school speech is reflected in the textbooks used in the different educational and professional areas. For example, in control engineering texts 10, the way in which the transfer function is determined does not change, comparing an updated edition against a previous one. Similarly, it occurs when another work is reviewed within the same discipline. 11. Something similar happens in other areas of knowledge. For example, in the field of administration, important concepts are taught, including various ratios and relationships that allow knowing the solvency, liquidity, and productivity of a business, known as financial ratios, such as the net present value, internal rate of return, balance point, among others. 28. Project evaluation should not consider the aforementioned coefficients in isolation, but should be analyzed comprehensively and together in order to provide validity, timeliness, and objectivity to the information that supports and bases decision-making in an investment project. In the science of management, the DME is present when the procedures to calculate these coefficients are shown, since many books in this branch of knowledge approach these concepts practically the same. However, despite the fact that many books are conceived by the DME, in various works in the different fields of study, it has sought to overcome the DME. For example, 29 an analysis was carried out for a bias circuit for 2 rectifier diodes in series, where an algebraic solution was proposed in terms of the parameters of the circuit components. In this way, it is possible to calculate the bias point of the circuit without falling into the DME that occurs in the classroom when teaching analog electronics, on the subject of rectifier diodes. In other words, it is customary to teach diode bias using the graphical method, where the diode curve is plotted against the load line of the circuit. Obtaining the polarization point for the circuit can also be obtained using numerical algorithms such as Newton-Raphson's 3031. In 32 an approximation was presented for the error function and another for the normal cumulative function, which have many advantages in their implementation, such as reducing computation times, but also seek to change an alternative in the teaching the use of the normal distribution to calculate a probability, and thus avoid the DME. IJERT 10 is 060100 www.ijert.org 301. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021. In this work, an alternative method is proposed to obtain the proof of the general formula to solve second-degree algebraic equations, and that can be taught to high school and engineering students. This article presents the solution through power series, presented in 33, which is not detailed, since this text assumes that the reader has a good background in mathematics, incurring the DME. In this way, it is sought to teach the solution method to students who are in the last semesters of high school and to university students who do not have a rigorous training in the area of mathematics. Also in this work, an analysis of significant digits in the roots of the quadratic equation is presented when the general formula is used or when it is applied in a rationalized way. The aforementioned concepts are not taught in conventional algebra courses, nor are they mentioned in algebra textbooks as they are influenced by the DME. The purpose of this paper is aimed at awakening the interest in mathematics to students and teachers in the area of mathematics, and is organized as follows. Section 2 presents the importance of the quadratic equation. In Section 3, the alternative deduction for the general formula for solving quadratic equations is presented. Section 4 presents the solution using power series. In Section 5, 2 case studies are presented. The first is about the computational implications when the general formula is rationalized. The second case study presents a comparison of the solution obtained through the general formula against the solution through the power series. In Section 6, the conclusions of this work are presented. 2. The importance of the quadratic equation. The quadratic equation 2 + equals 0, 1, represents a parabola, and its solution is of high importance in physics and engineering. In physics, it is used to solve mathematical procedures that lead to its solution. 34. In the area of ordinary differential equations, its usefulness is of high importance, since to give a solution to linear equations it is necessary to solve the characteristic equation, which in many cases presents a second-degree algebraic equation. 6,7. In engineering areas such as electronics, field effect transistor, FET, polarization analyses require solving Shockley's second-degree equation. 35-36. In electric circuit theory, the solution of the quadratic equation is also important. In some analyses, as the frequency response using Bode diagrams. 10, it is required to analyze the damping criterion in the response of an analog filter. 37-38. It is important to remember that the study of the quadratic equation begins in the introductory courses of algebra in secondary education in Mexico and deepens in the mathematics courses of the high school. However, different authors have made many proposals for the study of the second-degree equation in order to make the teaching of the second-degree equation and its geometric behavior meaningful. For example, in 39 a didactic design was proposed to re-signify the parabola and the graphic models related to situations of a person's displacement. In traditional textbooks used for teaching Algebra 4, solution procedures are presented using classical algebraic methods to solve the quadratic equation. In addition, notable products such as the binomial squared and difference of squares are studied when it presents the characteristics of being a perfect square trinomial, or when the form is incomplete, 2 + = 0. However, the general formula to solve these equations is very useful when we find coefficients that do not allow us to find their solution immediately. In 4, the proof is presented by adding terms and completing squares to obtain the general formula to solve quadratic equations, given by ±2 to 4 = 2, 2, 3. Obtaining in an alternative way the general formula, we begin by making equals plus, and substituting in equation 1, where is a complex number with real part given by, and imaginary part given by. Simplifying, we obtain 2 + 2 to 2 +++ = 0. 3. From 3, we get the real part and the imaginary part. Solving for the imaginary part, we have equals 2. 4. Substituting 4 in the real part, we obtain 2 4 to 2 + = 0. 5. From 5, we can see that it is easy to solve for, solving equals ±42 to 6. Substituting 4 and 6 into equals plus, we have equals 2 plus or minus 4 to 2 2. 7. Furthermore, taking into account that equals minus 1, equation 7 can be simplified, obtaining then the general formula given by 2. However, when 2 4, the numerical difference in the numerator can be very small. In these cases, it is useful to make use of double precision variables 40 when formula 2 is implemented in a programming language. To minimize the effects of cancellation due to subtraction, equation 7 can be rewritten as minus 2 equals plus or minus 2 to 4, 8. IJERT 10 is 060100 www.ijert.org 302. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 4. Solution by power series. The solution through power series is possible when there are perturbative parameters of being a constant whose restriction is 1. Consider the quadratic equation given by 2 plus 1 to 2 equals 0, 9, where 1 is a real integer constant and 2 a real constant. To solve this equation, perturbative methods used 33 are used. Now consider 0 plus 1 plus 22 plus 10, using the first three terms of the series and substituting in 9, we have 422 plus 3, 12 plus 212, plus 2, 11 plus 202 plus 12, plus 10 plus 201 plus 02, equals 2, 11, equating the coefficients of, we obtain, the system given by 0, 0 2 equals 2, 1, 10 plus 201 equals 0, 2, 11 plus 202 plus 12 equals 0. 12, solving the system of equations given by 12, and substituting the solutions of 0, 1 y2 in 10. The solutions in power series are given by 1 equals 2 to 1 2 plus 212 8 2, 2 equals minus 2 to 1 2 to 2 1 8 2 2. 13. V study cases. In the first case study, we analyze the behavior of the significant digits for the when solving the quadratic equation using 2 against 8. The second case study discusses the comparison of the solution calculated by the general formula against the solution obtained with perturbation in power series. For the development of the case studies presented in this work, the mathematical software Maple15 and its fsolve command have been used, which is an interbuild function that has a Newton-Raphson (NR) algorithm and that we will use as an exact solution to validate the results presented in this article. A significant digits using the general formula and its rationalization. We will consider the quadratic equation given by 2 plus 5 equals 0, 14, with solutions 1 equals minus 5 and 2 equals 0 when equals 0. To see the behavior of the significant digits of the roots of this equation, it is considered to give different values to, such that 1. Then, to determine the roots of 14, the formulas of 2 and 8 will be used. In addition, we will consider that the exact solutions are those that have been determined with the numerical differentiation NR. In 31 algorithms and their implementation are presented using a programming language such as C40 or Fortran 41. Table 1 presents the comparison of using equations 2 and 8 against NR for 1 to 5 1. Table I comparison of significant digits between equations 2 and 8 against NR. Table style C values 1 roots with 2 minus 5.19258240 roots with 8 minus 5.19258240 roots using NR minus 5.19258240 0.192824 minus 5.0199235 minus 5.019920635 minus 5.019920633 0.01992063367 minus 5.001999200 minus 5.001999550 minus 5.001999201 0.00199920064 0.00199920064 minus 5.000199990 minus 5.000200080 0.000199990 minus 5.000199990 0.000199990 E4 5.000020000 minus 5.00000000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000 minus 5.000000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000 minus 5.000000000 minus 5.000000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0000000.0 same expression. In other words, to obtain EQ, 8, it has proceeded to rationalize the numerator in 2. However, carrying out this process has a very important implication in numerical calculations, that the traditional books, following the DME, do not warn the student. In Table 1 we can observe the behavior of the significant digits of both roots in equations 2 and 8, as the value of is changed. For example, if equals 1 to 5, for 1 in EQ 2, the number of significant digits remains constant, whereas this does not occur for EQ 8. In the case of 2 in EQ 8, the significant digits remain constant, but not for EQ 2. In order to show the accuracy of the roots of the equations under discussion, we will use the formula 15 to obtain the significant digits 42, 43, given by SD equals log 10, 15, where SD is the number significant digits, is the exact value computed with NR, are the roots calculated with equations 2 and 8. Figure 1 shows the graphs of significant digits of the data is shown in Table 1. In EQ 2, the number of significant digits for 1 remains constant, in this case 11, while for 2 they decrease as tends to 1, that is, 5 significant digits. On the IJERT 10 is 060100 www.ijert.org 303. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021. Other hand, in the case of EQ 8, 2 is the root that keeps the significant digits constant, while 1 shows a reduction of these. From this figure an inverse behavior can be seen in the roots of equations 2 and 8. Fig 1. Comparison of significant digits in the roots from equations 2 and 8. From Table 1 and Figure 1 it can be concluded that the advantage of using the rationalized formula 8, when we have the condition 2 4, is that the number of significant digits can be maintained with good precision. To do this, in the denominator, both n 2 to 4 must have the same sign. When this condition is not met, it is better to use formula 2. B. Perturbative solution with power series. Consider the constants 1 equals 5, 2 equals 1, and equals 0.00, substituting into 9, we have 2 plus 0.005 to 1 equals 0. 14. In this case, the exact solutions are calculated with the general formula and have the same significant digits as those calculated with 13, given by 1 equals 0.997503125 and 2 equals minus 1.002503125. In Figure 2 the solution for 9 has been plotted with 1 equals 3 and 2 equals 2 for 1. You can see that very small values of the solution is very close to the exact value. For values of 0.15, the difference between the exact value and 1 begins to be made visible. Fig 2. Comparison between the exact positive root and 1 with 3 terms in series expansion. For small values of the approximate solution is closer to exact solution. 6 conclusions in this article. An alternative deduction has been presented using a complex expression for the general formula that allows solving quadratic equations. In the same way, the perturbative solution was presented through power series. 2 case studies were also presented. In the first, the behavior of the significant digits of the roots of a quadratic equation was discussed. This behavior, following the DME in traditional algebra books, is not analyzed, nor is anything commented on about it. On the other hand, in 30 the effect of rationalization is commented. However, also following the DME, the reader is presented with a detailed analysis of the advantages and disadvantages of rationalizing the general formula for solving these equations. In the second case study, the solution was discussed through power series, which was obtained through perturbation methods when there is a small parameter such that 1. In the example presented, 10 significant digits were determined, which shows a high accuracy when using this method considering the first 3 terms of the expansion to approximate the root. Likewise, Figure 1 illustrated that the accuracy decreases if we make it grow. Figure 1 suggests that to obtain an accuracy of approximately 95%, it is necessary to use a value 0.01. In this article we have presented some alternatives that can be used in algebra courses in teaching the quadratic equation. We believe that this work will provide an enriching experience, both for students and teachers in the teaching-learning processes, with which the school mathematical discourse that has been present in traditional books and in classrooms can be overcome from another perspective. This will allow proposing other teaching strategies for the benefit of students within the discipline of mathematics. Acknowledgement. Authors would like to thank MENG Roberto Ruiz Gomez for his contribution in this project. IJERT 10 is 060100 www.ijert.org 304. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 References 1 Lucena, FJH, Diaz, IA, Rodriguez, JMR, and Marin, JAM, Influencia del ala invertida en el rendimiento académico. Una revisión sistemática. Campus Virtuals, 8, 1, p. 9-18, 2019. 2 Arcio, FDB, Rojas, GH, and Gonzalez, ELG, Estrategias docentes para un aprendizaje significativo, una interpretación constructivista. McGraw-Hill Interamericana, 2010. 3 Carrer, CZ Diseño de Estrategias para el aprendizaje grupal una experiencia de trabajo. Perfiles Educativos, 1983. 4 Balder, J.A., Algebra, Editorial Patria, 2011. 5 Barnett, R. Algebra con Geometría Analítica y Trigonometría, Mexico, Lemus y Noriega, 1994. 6 Edwards, C.H., and Penny, D.E., Ecuaciones diferenciales y problemas con valores en la frontera, Pearson Education, 2011. 7 Zill, D.G., Ecuaciones diferenciales con aplicaciones, Editorial Iberoamerica, 1997. 8 Simmons, G.F., Differential Equations with Applications and Historical Notes. CRC Press, 2016. 9 Wazwaz, A.M. Linear and Nonlinear Integral Equations. Berlin, Springer, 2011. 10 Ogata, K., Ingeniería de Control Moderna. Pearson Education. 2003. 11 Diazo, J.J., and Constantine, D.H., Linear Control System Analysis and Design, Conventional and Modern, McGraw-Hill, Higher Education, 1995. 12 Kindle, J., Geometria Analytica, McGraw-Hill Seriashome, 1994. 13 Olvera, B.G., Geometria Analytica, Colección de, 1991. 14 Olvera, B.G., Geometria Analytica, Prentice Hall, 2006. 15 Ayers, F., Mendelssohn, E., and Avellanis, L., Calculo Differential E Integral. McGraw-Hill, 1994. 16 Purcell, E.J., Rigdon, S.E., and Varberg, D.E., Calculo, Pearson Education, 2007. 17 Leithold, L., AC7 Calculo, Oxford, 2012. 18 Stewart, J., Single Variable Calculus, Early Transcendentals, Cengage Learning, 2015. 19 Fox, W.P., Mathematica Modeling with Maple. Nelson Education, 2011. 20 Barnes, B., and Fulford, G.R., Mathematical Modeling with Case Studies, using Maple y MATLAB, Chapman, and Hall CRC, 2014. 21 Nakamura S., Analysis Numerical y Visualization con MATLAB, Pearson Education, 1997. 22 Almenar, M.E., Isla, F., Gutierrez, S., and Luig, M., Programa de Elementos Finitos de Código Abierto para la Resolución de Problemas Mecánicos en Estado Plano. Asociación Argentina de Mecánica Computacional, 36, p. 6-9, 2018. 23 Sanchez, JAM Investigaciones en Clase de Matemáticas con Geogebra, 13 Jornades de Educación Matemática de la Comunidad Valenciana, Innovación y Tecnología en Educación Matemática. Instituto de Ciencias de la Educación, 2019. 24 Torres Ramon, M., Applicaciones con VBA con Excel, Alpha Omega, 2016. 25 Soto, D., Gomez, K., Silva, H., and Cordero, F. Exclusión, Cotidiano y Identidad, una problemática fundamental del aprendizaje de la matemática. p. 1041-1048, 2012. 26 Soto, D, and Cantoral, R. Discurso Matematico Escolar y Exclusion. Una visión socio-epistemológica. Bolma, Boletim de Educación Matemática, 28, 50, p. 1525-1544, 2014. 27 Uriza, R.C., Espinosa, G.M., and Gasparini, D.R. Análisis del Discurso Matemático Escolar en los libros de texto, una mirada desde la teoría socio-epistemológica. Avances de Investigación en Educación Matemática, 8, p. 9-28, 2015. 28 Altuve, J.G., el uso del valor actual neto y la tasa interna de retorno para la valoración de las decisiones de inversión. Actualidad contable fases, 7, 9, p. 7-17, 2004. 29 Sandoval-Hernandez, M.A., Alvarez-Gasca, O., Contreras-Hernandez, A.D., Pretelin-Canela, J.E., Palma-Grayeb, B.E., Jimenez-Fernandez, V.M., and Vazquez-Leal, H. Exploring the classic perturbation method for obtaining single and multiple solutions of nonlinear algebraic problems with application to microelectronic circuits. International Journal of Engineering Research and Technology, 8, 9, p. 636-645, 2019. 30 Burton, R.L. and Fairs, J.D. Numerical Analysis, 8th edition, Senange Learning, 2005. 31 Chapra, S.C., Canale, R., Numerical Methods for Engineers, 4th M.C. Graw-Hill, 2004. 32 Sandoval-Hernandez, M.A., Vazquez-Leal, H., Filobello-Nino, U., and Hernandez-Martinez, L., New Handy and Accurate Approximation for the Gaussian Integrals with Applications to Science and Engineering. Open Mathematics, 17, 1, p. 1774-1793, 2019. 33 Holmes, M.H. Introduction to Perturbation Methods, Springer Science and Business Media, 2012. 34 Resnick, R., Halliday, D., and Crane, K., Physica Volume I, CECSA, 2004. 35 Boylestad, R.L., and Nashalsky, L., Electronica, Teoria de Circuitos y Dispositivos Electrónicos. Pearson Education Prentice Hall, 2003. 36 Stra, A., and Smith, K.C., Microelectronic Circuits, New York, Oxford University Press, 1998. 37 Hulsman, L.P. Active and Passive Analog Filter Design, An Introduction. McGraw-Hill, 1993. 38 Sadiku, M.N.O., Circuitos Electricos, McGraw-Hill, 2011. 39 Cordero, F., and Suarez, L., Modulation and Matematica Educativa. Acta Latinoamericana de Matematica Educativa Volume 18, p. 639-644, 2005. 40 Joyens Aguilar, L., and Zahanaro Martinez, I., Programmation and C., Metodologia, Algoritmos, Estructura de Datos. McGraw-Hill, 2001. 41 Marcus, A., Modern Fortran in Practice. Cambridge University Press, 2012. 42 Berry, D.A., Parlang, J.Y., Lee, L., Promer, H., Cunningham, C.J., and Stagnity, F., Analytical Approximations for Real Values of the Lambert W function. Mathematics and Computers in Simulation, 53, 12, p. 95-103, 2000. 43 Vazquez-Leal, H., Sandoval-Hernandez, M.A., Garcia-Gervasio, J.L., Herrera-May, A.L. and Filobello-Nino, U.A., PSEM Approximations for both branches of Lambert W with applications. Discrete Dynamics in Nature ANS Society, Hindawi, 2019, 15 pages, 2019. IJERT 10 is 060100 www.ijert.org 305. This work is licensed under a Creative Commons Attribution 4.0 International License.